Good evening, everybody. I hope that you've all had a restful weekend. I know it's sort of what are we in? Week 13? No, 12. Week 12? I'm losing track of the weeks, but we only have a few weeks left until, well, really, we have this week, the next week, and then the following week is going to be Thanksgiving. Um, and then we have 1 week after that, and then finals week. So really, we're looking at 4 weeks, but the holidays are going to be kind of disruptive because I know that, once we get to the holiday, that's all everybody's going to be thinking about. And so we just need to make sure that, whatever work, you guys can look at your grade and assess where you are in the class. I've done that. Grades are updated in Canvas for the most part. And for the most part, everybody's looking pretty good. Maybe we want to, go into test 3 with a little bit of practice behind our belt, because I know that graphing, what we've been doing lately, is a little bit more complicated. So just keep that in mind that we only have a little bit of time left in the semester, and we need to make sure that we're getting the practice and we're dedicating ourselves to finish off the semester strong. With that being said, I did get an email from a student in the class earlier today saying, did we have to complete the section 10.4 in Hawks? Because that homework assignment was assigned, and I had accidentally put the due date for today. But that was a mistake on my part. That due date is actually going to be for Wednesday, because we haven't covered that material yet. We're going to cover that today. So the things that we're due today, that what we've covered so far, is everything from 10.1 through 10.3. We looked at the Cartesian coordinate space, which was section 10.1. We graphed lines in 2 variables. I gave you a strategy for doing that, where you pick your x values, use the equation to find the y values, and then you plot those 2 points and draw a line between them. Then last class, so last Wednesday, we went over the slope-intercept form, which is a different take on a linear equation. It's just a different form, a new way to graph the equation. And in some sense, it's a little bit more intuitive, because as long as you have the y-intercept and the slope of the graph, you can just use that single point and the slope to find the next point, and then you can draw your line. Today, we're going to be going over point-slope form, but there's not much to this form. It's very similar to slope-intercept form in some ways. It's related to the slope formula, which I've given to you already. So we'll see how to use this, how to convert between slope-intercept form and point-slope form. And then we will cover graphing linear inequalities. So this is going to be similar to graphing our equations, but now we're not going to have an equal sign, and so the graphs are a little bit different, and we'll have to pay attention to what goes on there. Currently in Hawks, I also have the review for test 3, and that's going to be open until Saturday. Well, it's open through Saturday, right? Saturday at 11:59 p.m. Okay, because I was looking at the schedule, and it occurs to me that just to buy us a little bit of time, that what we're going to do for Wednesday, just giving you a heads up on what we're doing coming up in the next couple of classes. Wednesday, I told you last week, was when we were scheduled to take test 3. But I really want to give you guys more time to work on this review, despite not having enough days left in the calendar to give you that time. So what I'm going to do is I will open up this test review. Is already open. It opened at 6 o'clock tonight. So you can get in there and work on stuff as long as you understand the material, right? And you can do this as many times as you need to, just to get that practice. But it's going to be open until Saturday. What I'm going to do is on Friday at 12 a.m., so right first thing in the morning, test 3 will open up in Hawks. And so I'm going to give you from Friday through Sunday at 11:59 is when the test will close, to take that test on your own time. Does that sound good to you guys?
Yes.
Okay, now again, that's just so that we can free up some time in the calendar, but also it gives you this time frame so that while you're still working on these 2 homeworks, which are going to be due on Wednesday night, then you have time to work on the review and then time to get the test done by the end of the week. Okay, so I wanted to build in some flexibility for us. But the things are going to remain the same as far as the test taking. You're still going to have to upload your work onto Canvas, and without that work, I won't be able to grade your test. So if you do not upload your work in this time frame, then I will have to give you a 0, right? Because you have not done any work as far as I'm concerned. So, but again, I think that this is a pretty gracious thing for me to do. It gives us some flexibility so that, you know, if you have things that are coming up this week that are just completely throwing you off, as far as time management is concerned, those things happen. And I think that this gives you a little bit of wiggle room to get it done on your own time. Okay, does that make sense? Well, I hope it does. And I'm going to post this in Canvas later after class, just so that you have a reminder. It'll be an announcement. Does anybody have any questions about that?
I have a question, but about the last lesson.
Okay, yeah. What is your
Okay.
question about the last lesson?
Okay, the last lesson, I don't participate because I have the police in my house. I have other problem. Can I have all the note that the video that you make it? I send you an email
Yes,
for ask that.
I responded to your email. All of the notes are uploaded to Canvas already.
Okay.
Um,
Because I don't found it. And,
okay.
sorry, I
No,
have
you're fine.
I try do the 10.4, the
Mhm.
slope point, but
No, we haven't covered 10.4 yet. We're covering that today. So if you weren't able to get it done, that's perfectly fine. I pushed that deadline
no,
back to Wednesday.
I stop because found the point. I do the old exercise is wrong. Maybe I repeat it 10 times. I
Mhm.
say, okay, that's it. I stop and that's it.
Yeah,
I'm
so
stopping 5 question.
there are some questions in there that are similar to slope-intercept form, and they do ask you for slope-intercept form, which we've covered. But then
Mhm.
other ones ask you, what is the equation in point slope form? And because we haven't covered that, I didn't expect anybody to actually finish that. A couple of you guys did, and kudos to you guys, because you can always go into the learn section of Hawks to learn it on your own, right, to get ahead. And I'm assuming that that is what the students did, but we haven't covered that material. I'm going to cover it today. So if you didn't understand or were having trouble and just like, you know, banging your head against the wall, trying to understand what was wrong with those problems, it's probably because we haven't covered that material, and we're going to cover it today. But if you go into the modules for Hawks 410, right? I'm sorry, for Canvas Math 410, which is our class, elementary algebra, and you go into the modules and you scroll down to module 3, this is what we're working out of right now. And at the top of each of the modules, you should see lecture notes and videos. At the end of every night, after we're done with our lectures, I post the video and the notes that I write down. And if you scroll all the way to the bottom, you find the most recent one. Okay, so the stuff on 10.3 slope-intercept form, and the video is right here, the link to the YouTube video, but you could just maximize the video here and watch it in Canvas. But yeah, if you ever have questions like that, and you need to reach me in a very timely manner, I would send me a message in the Reminder app that we worked on at the very beginning of the semester, because those messages go directly to my phone. And if you send me a message in Canvas and it's right before the weekend, depending on how busy my personal life is, I might not get to that until Monday. But I did respond to your email, Katya. So you probably just didn't get around to checking. I'm not sure, but I did respond.
Sorry.
No, you're good. Does anybody else have any questions about? Let me go ahead and stop sharing. About the stuff about the homework or the test. Okay. All right. Let's jump into section 10.4 right now, just so we can get into it. There's not much more to cover here, so that's the nice thing. So here we go. Section 10.4. Point slope form. Okay, so far we've been learning about how to graph things in a Cartesian coordinate system. That is where we have the x-axis, the y-axis, and we can plot points and then draw a line between 2 points. And we have this graph that represents an equation. And so far you've been given these formulas or these linear equations in different forms. And so we have to sort of keep those separated in our minds just so that we're not confusing them. So the first one we learned was standard form. And that one was of the form ax plus by is equal to c, where a, b, and c were all just numbers. They're just constants, okay? And given an equation like this, we can choose x values, plug those in to the equation, solve for y, and then get an ordered pair, x, y, and then plot that point. Okay, so you might not think like if I've given you this, that I've given you that much information, but there's actually a lot of stuff that you can do with an equation like this. Similarly, we saw that some of the Hawkes problems expect you to be able to plot the line, but they only give you a single point. Whereas when we first started off, I said find 2 points. So with slope-intercept form, you just needed one special point, the point that we called the y-intercept, and a slope that describes how steep the graph is. And then we can find the equation y equals mx plus b. And using the intercept b, the y-intercept, and the slope m, whatever this number is that's next to the x, then we can use that property of the slope, rise over run, to plot our line, right? And we saw different kinds of lines. So we saw lines that have positive slopes. So whenever we had a line that was diagonal, like that, we said that this had a positive slope. If ever you get a graph that looks like this, where the line is going down into the right, this is a negative slope. So what I mean by that is that when you found m here, that was going to be a negative number. Whereas if you found m here in this equation, whatever the equation that they give you, that it's going to be a positive number. We also saw, and let me go ahead and, we also saw 2 other kinds of line graphs. One where we had vertical lines, just perfectly vertical lines, like so.
What can they say, Amazing?
And we said that these vertical lines, which have an equation that look like x is equal to some number, that it has a slope which is undefined. Whereas when we had a graph of a perfectly horizontal line, that line would have been perfectly flat. Well, maybe mine's not a great drawing, but this would have had an equation that was y equals some number where there's no x in the equation, and the slope of a perfectly flat line is 0. Okay. Another thing that we found was that all this terminology has the word slope in it, so you have to be very careful with these things. We use the slope formula where if you were given 2 points, x1 and y1, x2 and y2, that you could plug that into the slope formula, which was y2 minus y1 over x2 minus x1, and that would give you the slope of the line. We also called this rise over run. Okay, so let's just do some additional review, and let's jump into an example of a problem that we might encounter in Hawks. This problem says, graph the line with the slope m is equal to -3 over 4 and which passes through the point 2, 5. Okay, so if we look at this graph and we can plot the first point, right? We can go ahead and draw our Cartesian coordinate plane, and they've given us the point to plot, which is 2, 5. So I'm going to go over 1, 2, and then up 1, 2, 3, 4, 5. And where these points intersect, or where these two values intersect, that's where I'm going to put my first point. But notice that this point is not on the y-axis. So what we can say is that this point is not the y-intercept. And that's important because what I know is that if I wanted to use slope-intercept form, which is y equals mx plus b, then I would need 0, b, the y-intercept, in order to use the slope from this point to move and find the next point. However, even though I won't be able to put the equation, I won't be able to plug 5 in for b, because this is not the y-intercept. Remember, the y-intercept always has a 0 for the x value. I won't be able I can graph this using the same method that we were using last time, but I won't be able to find the equation. Okay, so this is just asking me, graph the line with this slope which passes through this point. Once you've plotted that point, we can use the slope the same way that we did on Wednesday, and the slope m tells us rise over run. Okay, so in that case, we're going to rise -3 and we're going to run 4. So I'm going to go down 3 and then over to the right 4. So I'm going to go down from here 1, 2, 3. And then from this point here, so really it's down 3 here. 1, 2, 3. And then I'll go over 1, 2, 3, 4. 1, 2, 3, 4. And this is going to be the location of my next point. That location would be 1, 2, 3, 4, 5, 6 in the x direction, and then 1, 2 in the y direction. So this point here is the point 6, 2. So we can still graph this thing, no problem, but we won't be able to find the equation quite as easily. Well, I got these 2 points here, draw my line straight through them. Okay. But now if we want to find the equation, we can't use this slope-intercept form because we weren't given the y-intercept. Right? We're going to need some new form. But that will be the graph of the line. And now we can actually talk about how would we get the equation of this graph if we're not given the y-intercept. Okay. So let's consider the slope formula. M is equal to y2 minus y1 over x2 minus x1. Or let me put the m on the other side, actually. Equals m. Well, if I wanted to manipulate this slope formula so that I get my points, my y's by themselves, y2 minus y1 over x2 minus x1 is equal to m, then this is just an equation. We can manipulate it using all of the techniques that we've learned up to this point. If we have x2 minus x1 on the bottom here and I need to cancel that out, I'm really dividing, right? A fraction is a division problem. So I have whatever y2 minus y1 is, that's being divided by x2 minus x1, whatever number that is. So what you can say is if we multiply on both sides, x2 minus x1, I can do this because I've multiplied the same thing on both sides of the equation, and so the equation's still balanced. But the nice thing about that is that when you multiply by a number and when you divide by a number, that these values will cancel out. So all you'll be left with is y2 minus y1 is equal to m times x2 minus x1. Should put a 1 here. And now we have the y's by themselves over here. Well, it turns out that this form where you have the y's by themselves over here and the x's over here with the m, this is called point slope form. And with point slope form, all you need is the slope, m, and you need any single point. on the line. So if we plug that information in, if we plug m into this, and then we plug any single point that we've been given that the line passes through or that falls on the line, we can plug that in to the equation for x and y, x1 and y1. So usually what they'll do is they'll drop this subscript of 2, this label of 2, and they'll put point slope form as y minus y1 is equal to m times x minus x1. But this is fundamentally the same thing. The point slope form equation is related to the slope formula that we've already been working with. So if we look back at that example we just worked, that example said to graph the line with slope m is equal to -3/4, passing through the point 2, 5. And we did that again really briefly by finding this point 1, 2, 1, 2, 3, 4, 5 right here, using the slope to go down 1, 2, 3, and then go over 1, 2, 3, 4. So 1, 2, 3, and then over 4 to find that other point. So this is 2, 5, the original point. And then we said that this one was 6, 2. And we drew a line through that. Well, the equation for this graph in point slope form would be given by this equation, y minus y1 is equal to the slope times x minus x1. And now we can plug in this first point that we were given and the slope that we were given for, we can call this one x1, y1, and that's our m. So then we can rewrite this as y minus y1 is 5 is equal to m, which is -3/4 times x minus, and then x1 is 2. And now we have an equation that has x and y in it. And that would be your equation in point slope form. So in point slope form, you don't have to worry about this second point. That's not going to be plugged into this, this skeleton, right? You're just going to use the single point that they gave you and this equation. I'm sorry, the single point that they gave you and the slope. So if the point slope form is something that we can now find just by plugging into this format, and we have y minus 5 is equal to -3/4 times x minus 2, you might ask yourself, well, why are we doing this and how is it related to slope-intercept form, what we did before? Well, why we're doing it is because you won't always be given the y-intercept. So if we're given any point, then we can still find the equation by using this formula. Okay, as long as we're given the slope and that point. Whereas with the slope-intercept form, we had to be given the y-intercept. But since the point slope form, all of these forms of the equation are interchangeable, we can just do a little bit of algebra and figure out how to get from the point slope form to slope intercept form if we needed to. So remember, slope intercept form is y equals mx plus b. So the goal here would be, if we're trying to transition from the point slope form to slope intercept form, we need to get this y by itself. Okay, so that we have y is equal to all the other stuff. Okay, so the way I would go about doing that is just a little bit at a time. You would distribute this number here and here, so that now we have y minus 5 is equal to negative 3/4 x. And then a negative times a negative would be a positive. And 3/4 times 2 is going to be, let me do my scratch work over here, right? 3/4 times 2 is going to be 6/4, which reduces to 3/2. 3/2. Okay. And then if we want to get this in slope-intercept form, again, I said we need to get the y by itself. So what we can do is just add the 5 over to the other side. So we can add 5 to both sides of this equation so that these cancel out. And we have y is equal to negative 3/4 x. And then we have to figure out what 3 halves plus 5/1 is, right? I want to do this part. Well, if I multiply this by 2 and 2, I can get 3 halves plus 10/2. So that's going to be 13/2. So the equation here would be y is equal to negative 3/4 x plus 13/2. And this is slope-intercept form. Seems like a lot. I'm sure that it seems like I whipped through that really quickly, and to be honest, I did. Because it pulls in a lot of the information that we've been learning throughout this semester, right? Like if you're still rusty on distributing, then that would have been a hiccup, right? If you are rusty on multiplying fractions, when we multiplied this number times 2, then that's a little place where you hit a little bit of turbulence. You get a little bit of resistance there, but we could do the scratch work to the side, get our 3/2 here, and then adding fractions to a whole number. We have to remember how to do that. You have to get a common denominator, or you could just use the calculator at this point, right? There's definitely no shame in that game. The calculator is there for us to use so that we don't have to be bogged down with remembering, well, what is the rule for multiplying fraction in a whole number? What's the rule for adding a fraction in a whole number? Because we're doing a lot more of that arithmetic as just acrobatics on our way to get to whatever form of the equation they're asking for. Okay. So let's take a look at another one. So this is what we're going to do. Example 2. First, I want to be able to graph the line passing through the point 2, 3. with a slope of -1/2. Give the equation of the line. And we'll say in A, point slope form, and B, slope intercept form. Okay, so really it's a three-part question, and I just want you to be able to flex these muscles, right? To be able to graph, to be able to give me the equation in point slope form, and then to be able to use algebra to manipulate that point slope form to get into slope intercept form. Okay, so what you want to do is take inventory of what's been given to you. You're going to have to, pay attention to the details in the question. You're going to have to read the entire question. Do not just skim it. Okay, and ask yourself, what did they give me here? And what they've given me is a point, which is 2, 3. And I know that this is the x value, x1, and this is the y value, y1. I also know that this is not the y-intercept, because the y-intercept will always have a 0 for the x value. They've also given you the slope, m, which is equal to -1/2, right? So this has been given to you. So first we need to focus on graphing this thing. And the graphing part shouldn't be too difficult, right? We can just draw our Cartesian coordinate system. One, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 6. Okay, and then we can plot the first point, right? So we're going to go over 2, up 3. And that's where we're going to plot our first point where those two coordinates intersect. That is 2, 3. Okay. Is everybody clear on how you get that? Or is there anybody who's not clear on how you would get that point? Okay, now since they've given us the slope, and I said that the slope is equivalent to rise over run, and we know that rise is going to be -1 and that run is going to be 2, well then I'm just going to go down 1, I'm going to go over 2, and that's where I'm going to put my next point right here. And if you want to mark it with the location, that'll be good practice. 1, 2, 3, 4, 4, comma, and then we went up 2. Okay, so that's where the second point is located. And now that we have 2 points, we can just draw a line straight through this, straight through those 2 points, as straight as we can get it, right? And you can ask yourself at this point, does this line make sense? And what I mean by that is just looking at this slope, what should the sign of the slope be? Should it be a negative or should it be positive? Well, this line, if you're riding it like a roller coaster, is going down. So because this point is lower and this line is traveling in a downward direction, well, that should be consistent with the slope that they gave you. And the slope they gave you is negative. So this one checks out because we do have a negative slope. If for some reason they gave you a negative number here, but you went up and to the right too, you would have a line that goes up like that. And so that would be sort of inconsistent, right? That would tell you that you've done something wrong because the slope is not matching the picture. Okay. So this is the graph. We've completed the first part of this question. And now we have to give the equation in a point slope form. Okay. So at this point, you'll have to have the point slope form, the bones of it, if you will, just handy. Just have that formula handy. So what I mean by that is just write y minus y1 is equal to m times x minus x1. Okay. And we've been given both x1, y1, and we've been given the slope m. So I can take these values and plug them into this point slope form. So I can say that the equation for this line should be, I'm going to leave these alone. Actually, let me highlight that, right? You're going to leave this y and this x alone. The only thing that you're plugging in is the one that has the little label, the x1 and the y1. Okay, so all we need to do here is leave the y alone, minus y1, and y1 is going to be 3. That's equal to m, which is negative 1/2, times, you're going to leave the x alone, minus x1, which is 2. And so this is the equation in point slope form. So that's the equation of the line. And we can manipulate this if we wanted to get it into slope-intercept form. So let me go ahead and write this on another sheet of paper, I think, because we won't have enough space down here to continue working. So it's y minus 3. We have y minus 3 is equal to negative 1/2 times x minus 2. And remember, we're trying to go from point slope form to slope intercept form. And to do that, we just need to use and flex some of our algebra skills, right? We just need to distribute the number in front of the parentheses. And the nice thing about multiplying 1/2 times something is that it's pretty easy to multiply 1/2 times a whole number. So we'll have negative 1/2 x, and then 1/2 times 2. You can ask yourself, what is half of 2? And that's just 1. Negative times a negative is going to be a positive. 1/2 times 2 is just 1. So we have y minus 3 is equal to negative 1/2 x plus 1. And to get this into slope-intercept form, we just need to add or subtract something over to the other side. But basically to isolate y. So I'll just add 3 to both sides so that this negative 3 and this positive 3 can cancel out. And we have y is equal to negative 1/2 x plus 4 now. And this is of the form y equals mx plus b. So this is our slope-intercept form. So what I'm saying is that you have point slope form here, which basically can take any point that's not the y-intercept, and this can give you the equation. This equation can give you all of the points that fall on that line that we graphed earlier. And that's related to this thing, y is equal to -1/2 x plus 4, that somehow these two equations are related to each other. In fact, they give you the exact same graph. So both equations produce the exact same graph. So it all just comes down to what information did they give me, and that'll help you determine whether you need to use point slope form to find the equation, or you'll need to use slope-intercept form to find the equation. But both of these things are interchangeable. Okay, so for some of the questions in Hawks, they'll ask you to find the slope, or rather they will ask you, find the equation of the line given only 2 points. Find the equation of the line given the 2 points. And the first point is -1, 2, and 4, -2. They haven't given you a graph, they haven't given you a picture, and they're expecting you to find the equation. Okay, so here's where we're going to put it all together, more or less. The first step is that as long as we have one of the points and the slope, we can get the equation. But we'll need to find the slope first. And so that is going to be the first step, find the slope using the slope formula. Okay, so the slope formula is m is equal to y2 minus y1 over x2 minus x1. And we've used this equation a couple times already. So we should know that, go ahead and label the points that they gave you. If this is point 1, this is x1 and y1. And if this is point 2, then that'll be x2 and y2. Now we can go ahead and plug those numbers into this equation and say that, okay, y2 goes here, so we have -2 minus y1, which is 2, over x2, which is 4, minus x1, and x1 is -1. So I would say if ever you have minus a negative number and the negative signs are right next to each other, then just go ahead and change that to addition. -2 minus 2 is on the top, and then we can call this 4 plus 1 on the bottom. So we can start to simplify the numerator. -2 minus 2 should be -4. And then 4 plus 1 is 5. So this number here, since it can't be reduced, that's our slope. Now, if they're asking you for this will be step 2. If they're asking for the equation in point slope form, then we can use the slope and we can use this first point, x1, y1. So if they ask for the equation in point slope form, then we need this equation, which is y minus y1 is equal to m times x minus x1. But we also need the slope, m, which we found already. And we'll need the point. And the first point is the one that we'll use, -1, 2, the first point that they gave us. And the slope we just found in step 1, so -4, 5. And again, we're just going to plug these values into the equation and just call it a day, right? That will be the equation of the line. So that means I'm just going to leave this as y minus, and then y1 is going to be 2 is equal to my slope, which is -4/5 times x will stay the same, minus x1, and it'll be minus, and this is -1, so we have to put -1 in parentheses. Okay, so anytime you have a minus and a minus, in order to simplify that, because Hawks won't accept this. Hawks will expect you to simplify it just a little bit further. But whenever you have a minus minus, you're going to need to change that into a plus because it just makes more sense. It's simpler to just say plus instead of subtracting a negative. So y minus 2 is equal to -4/5 times x plus 1. And that is the equation of the line. Does anybody have any questions about that? Okay, so there's a third step, possibly. Now that is if they don't ask you for the point slope form and they ask you for the slope intercept form. So step 3. If they ask for slope intercept form of the equation, then we're going to start with our point slope form. And point slope form we just found to be, let's see, y minus 2 equals -4/5 x plus 1. Y minus 2 is equal to -4/5 times x plus 1. Okay. And then we'll use the steps that we've already previewed in some previous questions to go ahead and distribute this number Unfortunately, in these problems, they keep giving us fractions for the slope. So you'll just have to remember how to distribute a fraction. Go ahead and multiply this number by x and this number by +1. So what we should end up with is equal to -4/5 x. And then negative times a positive will be negative. 4/5 times 1. Well, anything times 1 is just going to be itself. So that'll be 4/5. And we'll have y minus 2. So if we want to isolate y now, then we're going to have to add the 2 over here to this fraction. And that's sort of the unfortunate part of them continuously giving us fractions. We're just going to have to throw that into the calculator, or we're going to have to do it by hand. So don't mind me. I'll just be working that out by hand. Y is equal to -4/5 x minus 4/5 plus, I'm going to call this one 2 over 1, right? That's the same thing as 2. But now I need a common denominator. So I'll go ahead and multiply this fraction by 5 over 5 so that I now get -4/5 plus 10 over 5. And then these will combine to give me 6 over 5. And that doesn't simplify. So I'll just bring everything down. Because this is positive, I'm going to put a plus here. And I'll just bring everything down now. -4/5 x. And then my y. So y equals mx plus b. So this is the equation in slope-intercept form. Okay. So what I want to do is jump into the homework just so we can see, get a feel for what those questions are going to look like when we get there. Okay. So let me go ahead and share my screen. Okay, and point slope form is the section that we're on right now. So let's jump into practice. Okay, so notice that this question is asking us, find the equation in slope-intercept form with the given slope that passes through the point with the given coordinates. Okay. So here, if you're crafty, you can avoid doing some extra work. Okay. So first you have to notice that they've given us the slope, that is going to be m. And they've given us this ordered pair, this point, which you could call x1, y1. But does anybody notice anything special about this point?
The 0?
Yes. So if you have 0, comma, the number, then that's our special point, the y-intercept. So what I'm saying is that if you're observant enough to see that they've given you the y-intercept and that they're asking you for slope-intercept form, then you can just write down the equation y equals mx plus b, and then just plug in your m and plug in your b. So this is just going to be 3/8 x. And then it's plus this negative number. So we're just going to put -6/7. And that's all you have to type in. Okay. So I've sort of been previewing this question saying that we're going to have to put it into point slope form. And then we're going to have to do some algebra and distribute something and then add something over to the other side. And then we can get slope-intercept form. Well, like I said, if you're observant enough to see that they've given you the y-intercept, then you can cut out a lot of that extra work, and we can type in y equals 3/8x minus 6/7, and that should be your answer. Does anybody have any questions about this particular problem? Would you like to see me try a similar one?
Yes.
Okay. So let's do that. Let's jump into a similar one. Again, different slope, different point, but same question. Find the equation in slope-intercept form. So again, as soon as you see slope-intercept form, you should think to yourself, let me go ahead and write this equation down. Y equals mx plus b. That's slope-intercept form. And we need to plug in this slope and this point. And luckily, they've given us 0, b, which is our y-intercept. So they've cut out a lot of the work for us. So we'll just go back to our equation and say that this is y is equal to something x plus something else, or minus something else depending on the sign. And then we'll just plug in our values that they give us here. M is going to be negative 1/3. And then this is minus 4/9. And that's your answer. Does that seem deceptively simple? Are you guys still waiting for the trick? Boom. Any questions about that one? Okay, let's go to the next one and see what they'll throw at us. Okay, so notice that they're saying in this one, find slope-intercept form. So as soon as I read that, I'm thinking to myself, let me go ahead and write that equation down, just so I have the bones laid out. Y equals mx plus b, that's slope-intercept form. But this time they've given us a slope that is 5, which is fine, nice, it's a whole number. But this is not the y-intercept. Well, that means we're going to have to do some work. That means that we're going to have to go from point slope form and then rearrange it and get to slope-intercept form. So does everybody understand that logic, or is there anybody that I'm losing, right? Because I want you guys to be able to read these questions and like understand what they're asking and why we have to do this one differently than the last one.
So all the y-intercepts have to start in 0?
Yeah, y-intercept by definition has an x value of 0. So because this particular point that they gave us does not have a 0 for the x value, it has a -4, then we're going to have to do some extra work. So what that extra work looks like is going to be, we're going to set up point slope form which is y minus y1 is equal to m times x minus x1. And we've been given our m here, it's 5, and we've been given x1 and y1 here. So all we have to plug in, okay, we're going to leave the y alone, minus y1, and y1 is -1. So we'll put minus -1 is equal to 5 times x minus x1, which is -4. And now we have to start simplifying this. So anytime you have negative, negative, you'll just change that into y plus 1. Just because it makes more sense, it's much simpler to read it that way. Y plus 1 is equal to 5 times x, and then again we have this minus minus, so we'll call that plus 4. So this would be point slope form, but just to demonstrate, you know, if you are asleep at the wheel and you think, oh, I got it, let me go ahead and type that in. Y plus 1 is equal to 5 times. Well, they're not letting me put parentheses in. It gives me this message saying that this character you entered is not required for this answer. So that means I can't put parentheses, so they're trying to stop you from putting point slope form. So in order to go from point slope form to slope intercept form, we're going to have to distribute and then move some stuff around just so we can isolate the y. So I'll go ahead and distribute here 5 times x and 5 times 4. So we'll get 5x plus 20. And that's equal to y plus 1. And then all you have to do, in this case, we don't have any fractions, so this is really nice. All we have to do is isolate the y. So I'll subtract 1 from both sides so that these cancel out. And you should be left with y is equal to 5x, and then 20 minus 1 is positive 19. So this should be the answer that they're looking for in slope-intercept form. So I'll go ahead and delete everything that I was trying to type in before. And I'll put y is equal to 5x plus 19. And then I'll submit my answer. Again, at the top of this problem, I said, if you notice that they don't give you the y-intercept, that's when you're going to have to do a little bit more work. You're going to have to go from point slope form and convert that to slope-intercept form. So that's what you have to be watching out for. Okay, again, same kind of question. Find the equation in slope-intercept form when they've given you this for the slope and this ordered pair, which tells you that this is not the y-intercept. So we're going to have to go from y minus y1 is equal to m times x minus 1. And convert that somehow to y equals mx plus b. Well, this is pretty straightforward. As far as plugging things in, we'll have y minus some number. In this case, y1 is going to be -3. That's equal to m, which is in this case going to be 4/3, times x minus, and then -4 is what we're plugging in, -4. Then we just need to simplify this a little bit. Y plus 3 is equal to 4/3 x plus 4. And again, that would be perfect in point slope form, but they want slope intercept form. So we're going to have to do the extra work of distributing this number. we'll have 4 over 3x plus 16 over 3 is equal to y plus 3.
I have a question.
Yeah.
So are we always going to take, like how it has the -4 and the -3, we're always going to take that and use that as y, take minus -3 equals, and then we're gonna separate them and still always put them in that format?
You mean like going from this step to this step?
Yes.
Yeah, so you're always going to use this initial equation, point slope form, this guy over here, and just plug in those numbers. X goes here
Okay.
and y goes there,
Okay.
right? But the formula has a negative sign in it, right? So
Right.
if you put that negative sign and then you have a negative number, that's when it switches signs to a positive.
Okay, got it.
Yeah. So if you wanted to, like right off the bat, you don't have to write it out as minus -3 or minus -4. You could just say, okay, I see that, if it's a negative number here, it's going to flip in the formula. So just write it as a positive.
Okay, got it. Thank you.
Yeah, good question. Any other questions up to this point? Because we're not quite done, right? We still need to get the y by itself. Well, to get the y by itself, we'll have to subtract 3 on both sides of the equation. And these cancel out, but now we have to figure out what this is. So 16 over 3 minus 3 over 1. Well, we need to multiply this by 3 over 3 so that we get 16 over 3 minus 9 over 3. And that will be 7 over 3. And so this number is what's going to go over here. We'll have y by itself now because these canceled is equal to, this will stay the same, 4/3 x. And then we combine these numbers to get 7/3. So that's going to be positive 7/3. And the thing that's most frustrating about these problems is the arithmetic. So it may be that you're doing the process right, but if you forget how to add a fraction and a whole number or subtract a whole number from a fraction, like that's the part that is going to be frustrating. Y equals 4 over 3. 4 over 3. Four over 3x plus 7 over 3. And then you just let go and let God. Hopefully things have worked out, and they did in this case.
Can you ask where you found the 7? I'm lost.
The 7 came from 16 minus 9.
Where I pick it up the 9?
Excuse me?
Can you re-explain me the passage when I cancel the 3 under 3, whatever,
Oh, okay.
epsilon plus 3, the last passage, the last.
Yeah. We had 16 over 3 and we were subtracting 3. Which is the same thing as 3 over 1. Right? But you can't just subtract these. Like if you are still, and I'm not talking to you specifically, if any of you in the class are still under the impression that to subtract fractions, you'll just subtract 16 minus 3 and get 13, and then 3 minus 1 and get 2. That's not how you add or subtract fractions. Okay, so if we had 16 over 3 minus 3, you have to get a common denominator first. And in order to get that common denominator, I need to multiply 3 on the bottom here so that I get 3 times 1 is equal to 3. Well, if I multiply 3 on the bottom, I have to do that same thing on the top. So that's why 3 times 3 on the top is 9. So now that I have 9 over 3, I can take 16 over 3 and subtract that number. And that's where I got 7 over 3, which is this part.
Thank you.
So we can't forget how to add or subtract fractions because they're not going away. We're going to have to be able to do that with arithmetic. But if you are, feeling a little bit anxious about fractions, you're able to use calculators here. So if you can leverage your use of the calculator to help you with fractions, then do that, right? Because we have sort of bigger fish to fry. Let's take a look at the next one. Okay, so this one's really nice, actually. It's asking you to find the equation of the line and enter the answer in point slope form. So what we need to be able to do here is look at the graph because they haven't given us any points. They've only given us the graph. Luckily, the line graph has all the points on it that we'll need. So what we can do is, and you'll be able to do this better on your computer than just watching my screen, but we can zoom in and we can just pick a point, any point, and then actually we can pick 2 points and find the slope just by thinking about rise over run. So maybe I pick this point here. Let me go ahead and draw a point. Maybe this one right here. And then I pick another point to the right of it, right here. That looks like a good point. And the distance between these points, I would have to go down 2 and then over 1, 2, 3, 4. So I know that the slope, rise over run, is equal to -2 over 4, and that reduces to -1/2. So this has to be my slope. And you might be wondering, okay, well, why did you pick those 2 points? And my answer to that question is, it doesn't matter what 2 points you choose as long as they're on the graph. So what we can do is zoom into another point on the graph and say, let's say that you didn't like the 2 points that I chose, and you went with these 2 points over here, this one here, and this one here. And you were still trying to find the slope, m is equal to rise over run. Well, you would still have to go down 1, 2, so that's -2, and then over 1, 2, 3, 4. So you would get -2 over 4, which reduces to 1/2, -1/2. So you'll, regardless of the 2 points that you choose, as long as they're on the line, rise over run will give you the correct slope. Okay, and now if it's a fraction that can be reduced, you do need to reduce it so it's in simplest form. So in order to get this equation in point slope form, we only need, and that's the reason why it's called point slope form, right? It's called point slope form because you only need a point and the slope. So we have the slope. You can choose this point here, and we could say that that point is, I don't know, if this is -5, this is -10, 6, 7, 8, 9. Oh, this is 10, 11, 12. Then this is -12, and then 5. We could say that one of the points is -12, 5. Call this x1, y1. And then we can just use our equation, y minus y1 is equal to m times x minus x1. And the equation will now be y minus y1, which is 5, equals our slope, which is -1/2, times x minus x1 would be x. In this case, it would be plus 12. And this is the answer. This is the equation that they're looking for. And so there's an infinite number of equations that will work for this particular problem. Because if you didn't choose -12, 5, and you chose a different point on the line, like if you chose, let me erase some of this. Let's say that you chose this point over here, which looks like it's at 4, comma, you would go down 1, 2, 3, so -3, and called that x1, y1. Then you would get the equation y minus, actually, minus y1, so that would be +3, is equal to -1/2. The slope would be the same. And then x minus 4, this equation would work also. Hawks would accept either one of those. So the point doesn't matter. The slope here does. As long as the point is on this blue line, it will work and provide you with an equation that will work in Hawks. So even though this red equation that I put up here looks really different from the orange equation that I put down there, either one of them will work. So let me just put the red one in. Y plus 3 is equal to -1/2 times x minus 4. Okay, and then hit submit, and it should take it. Okay, so the steps here are to find the slope and then find any point on the line and then plug those into the point slope formula. So let's do another one just so we can see it all put together. So the first thing I want to do is find the slope. And we can zoom in. And just sort of measure rise over run. You know, you don't even have to calculate anything. We can say we have a point here, we have another point here. So we'd have to go down 2 and over 1, 2, 3, 4, 5, 6. So that would be a slope of -2/6, which reduces to -1/3. There's our slope. And then if you're particularly fond of this point right here, and you notice that that point is 1, 2, 3, 4, 5, 6, and then it's up 5, 6, 7. So this is 6, 7. We can call that x1 and y1. And then the second part of this problem is just to find the equation, right? So the equation is going to be y minus y1 is equal to m times x minus x1. And we're just going to plug in those values that we have. So this is going to be y minus y1, going to be 7. So y minus 7 is equal to the slope, which we found to be -1/3, times x minus 6. So this should be the equation that they're looking for. y minus 7 is equal to negative 1/3 times x minus 6. Does anybody have questions about this one?
How did you know to start like right where the under the 5 and go up?
Under the 5 and go up.
For when you did the rise over the overrun.
Oh, you mean
Like where you did from 5 up to this 1, 2, 3, and then how did you know to start right there?
oh, because I didn't want to bother counting from 1. I didn't want to start here and say this is 1, 2, 3, 4, 5, because they've already told me that this is 5.
Oh,
And
okay.
I was trying to get to this point, so I just started at 5 and called it 5, 6, 7.
Got it.
Yeah. Yeah, that was just laziness on my part,
Okay.
or expediency because of experience, right? Like I can cut corners because I'm a little bit more experienced at navigating the Cartesian coordinate plane. But if you need to start counting, you know, from 0 and count 1, 2, 3, 4, 5, 6, 7 to get to this point, then definitely do that. Whatever's going to result in fewer mistakes on your part. Good question, though. Any other questions? Okay. Well, now that should be enough to get you guys going for 10.4, but I want to finish up 10.6 also, and there's not that much more here. Even though it's its own section, it's still graphing these lines in the Cartesian coordinate space, but just in the same way that we solved the equations, now we're going to have to graph inequalities. So let me go ahead and write the header for this one. So section 10.6 is all about graphing linear inequalities in 2 variables. And sort of our bread and butter in algebra, at least in this graphing section that we're talking about right now, our bread and butter is going to be slope-intercept form because it makes things way easier. So if we have an equation in slope-intercept form, that is our y equals mx plus b. Okay, but now we're going to be dealing with inequalities. So an inequality in slope-intercept form will look like one of these. Either y is greater than mx plus b, y is less than mx plus b, y is greater than or equal to mx plus b, or y is less than or equal to mx plus b. Okay, so the only thing that's new here are that we're going to be using these inequality symbols for some of these problems. Okay, and they're going to change a little bit about how we graph, but not much. Okay, so let me just, I think that the only way that we're going to like really approach this thing is by jumping into a problem. I'm going to explain it as slowly and as clearly as I can. and then we'll do some problems that are a little bit more sped up. Okay. So the problems are going to say things like this: graph the solution set to the inequality. And so what we're saying here by solution set is something that's a little bit more interesting than what this equation was originally telling you. So when we graph these equations and we had an equal sign, if we had the slope and we had the y-intercept, then this part of the equation is telling you what the line looks like. Almost like before you graph it, it's telling you, if you could imagine in your mind's eye what the intercept is and what the slope is, you can sort of graph it in your head, or at least when you're experienced enough with it, you can start to think about, oh, this is a positive slope, so a positive slope is going to run in this direction, whereas a negative slope is going to run in this direction, right? And then if I have like a positive y-intercept, then the y-intercept is going to be above 0. If I have a negative y-intercept, then it's going to be below 0 on the y-axis. So you can think about this part of the inequality as telling you what the line is looking like. And we'll see that instead of just having a line, when we graph these, the solution set's going to be a lot bigger than just the line. Okay. So let me stop waving my hands at you guys and let's actually jump into a problem so you know what I'm talking about exactly. So example 1. Graph the solution set to the inequality. And they're giving us 2x plus y is less than or equal to 6. Okay, and so I'm just going to give you one general method that's going to help you graph this. So first, this inequality is given to you in standard form. So this inequality is in standard form. So that means your x and your y are on the same side. You have ax plus by is less than or equal to c. The first step is going to be to change this to y equals mx plus b form. And I'm being loose with the equal here. All I'm saying is put it in the slope-intercept form. We're going to keep this inequality symbol the same way it is unless I divide by a negative number. Okay, but we'll cross that bridge when we get there. The inequality is going to be treated just like the equal sign for the most part. I can add and subtract anything that I want to the inequality as long as I do it to both sides. So let me write this inequality down so I can start working on it. Okay, I want to move the x over here because I want the y by itself. So I'll subtract 2x from both sides so that my 2x and my negative 2x here will cancel out. That will leave me with y by itself. Y is less than or equal to. And then if I want this in slope-intercept form, then I want the x term first. I'm going to put minus 2x And because this is a positive 6, I'm going to put plus 6. Does anybody have any questions about that part? Because this is in slope-intercept form now. Okay. Now that I have slope-intercept, well, I know that the slope m is equal to -2, or you could call this -2/1 if you wanted to, so that you have rise and run. And then my b, or 0 comma b, is going to be 0 comma positive 6. That's my y-intercept. Is everybody okay with that? So using these two pieces of information, I should be able to graph this line. But let's go ahead and put the first point. We'll use the y-intercept and the slope to plot the 2 points first. Okay, and then we'll be careful as we draw our line. So we need to be at 0, 6. So 1, 2, 3, 4, 5, 6. I'm going to put a point right here. Okay, and now my slope is telling me if this is rise over run, go over 1. So I'm going to go down from 6 to 5 to 4. Then I'm going to go over 1. So my next point should be right here. And now you want to be careful, because you do not draw the line through these 2 points the same way that we did for an equation. Because this is an inequality, the inequality will dictate whether it's going to be a solid line whether it's a solid line or a dashed line. Okay, so what do I mean by that? If you have an equal sign, right, when we had these equations, y equals mx plus b, I said just draw a straight line through those 2 points. So if there's an equal sign, I can draw a solid line. So if you have either of these 2 symbols, then you can draw a solid line, because they have a little equal bar underneath them. But if you have this symbol or this symbol where you don't have the equal sign, then we're going to have a dashed line. Well, luckily, this first example has that inequality with the equal bar here. Y is less than or equal to this line. So that means I can just get my straight edge out and draw a line straight through these 2 points that I found. Right, and again, I found the 2 points by plotting the y-intercept, and then I used the slope to go down to over 1 to get the next point. Okay, so there's my solid line. And this is something that we didn't talk about for just strictly equations when this was a plain equal sign. But if you think about this Cartesian coordinate space that I drew, the line that I drew here separates the region into something that's above the line and a region that's below the line. So all of this is below the line. And when you graph inequalities, you're going to have to choose whether or not to highlight the region above or below the line, because that's what this graph is telling you, or this is what the equation is telling you, that the y values have to be less than or equal to this part, which I like to say that this is telling you highlight blank, and then this part is telling you where the line is. Okay, what I mean by that is we need to highlight the region that's less than or equal to the line. So if you think about it that way, the inequality is saying that we need to highlight the region below this line because this says y is less than or equal to the line. So since this is less than or equal to, what we want to do is highlight everything below the line. And that will be the graph. So with these inequalities, you're not only going to draw a line, you're going to choose either a region above the line or below the line, and that's what you're going to highlight. That's what the question's meaning when it's asking you to graph the solution set for the inequality. And that's that every single point below the line is a solution that satisfies this inequality. So I could choose a random point over here, and you could call this point, -10, +3, -10, +3. And if I plug it into this equation for the x and y, 3 is less than or equal to, and I plug the -10 in here, then if I solve it, I will get a true statement. That's all it means, right? But we don't have to do that extra work. I'm going to here just to demonstrate what I'm talking about, right? If this is my x and this is the y that I choose, and if this is in the highlighted region, that's the solution set, all of the points in this region. Then if I plug these two numbers into the equation, if I get 3 is less than or equal to -2 times -10 plus 6, and I simplify this, I will get 3 is less than or equal to, this will be +20 plus 6, which is 3 is less than 26. And this is true. So that's what we mean by that this point here is in the solution set. Okay. But just to sum this up, right? Because that was sort of a lot. Here are the steps for graphing the inequality. 1, get the inequality into slope-intercept form. So it should look like y equals mx plus b. But remember, these are inequalities, so you won't have an equal sign. It will be one of the inequality symbols. Once you have that, plot the y-intercept and use the slope to find a second point on the line. Remember, you're going to be using the slope as rise over run. So then we're going to draw a line, but these inequality symbols get a solid line because they have the equal sign. And these inequality symbols get a dashed line. And then what you need to do is interpret the inequality to find the correct shaded region. Okay, so if you have y is greater than or equal to mx plus b, or y is greater than, so this is greater means above. If you have an inequality in this form or this form where you have greater than or equal to or just greater than, then you're going to be shading the region above the line. But if you have y is less than or equal to mx plus b, or y is strictly less than mx plus b, then you're thinking to yourself, this is less than, so that means you're going to shade below the line. Okay. So let's do another example, and then we'll jump into Hawks and see what it's going to present us with in the homework. So example 2 from this section is that we want to graph the solution set to the inequality, and they're giving us 9x minus 3y is less than or equal to 21. So let me write this equation down really quick, or this inequality rather. And so you have to be careful when you're converting this to slope-intercept form, right? So again, that'll be our first step, convert this to slope-intercept form. So what we'll do here is subtract the 9x from both sides so that the 9x's here cancel out. We'll get negative 3y is less than or equal to. And then we want to put this in slope-intercept form, so you want to put the x term first. Negative 9x plus 21, again, because this is a positive 21. Now here is where I anticipate a lot of students to make some mistakes and to run into some frustration. Because with inequalities, when we were solving equations and inequalities last chapter leading into test 2, when you solve an inequality, we need to get the y by itself. So we'll divide everything by negative 3, but you flip the inequality when you divide by a negative number. So what we should be getting here is that these 3's cancel, you get y, but now we're going to flip the direction of the inequality. And then we can continue just dividing by this negative 3. So negative 9 divided by negative 3 will be positive 3x minus, because this is 21 divided by negative 3, minus 7. Okay, so this is slope-intercept form. You just have to be careful about this inequality. Okay, so once we have it in slope-intercept form, we can go ahead and graph this thing now. So 2, use the equation to graph 2 points. So we can draw our Cartesian coordinate space. And we know that -7 is the y-intercept. So the y-intercept is 0, -7. So I'm going to go down 1, 2, 3, 4, 5, 6, 7. And that's where I'm going to put my first point. And then I'll use the slope, which is 3, and it's easiest to use it as a fraction, 3/1, which tells us to go up 3 over 1. So we're going to go up 1, 2, 3, and then we're going to go over 1 to right here. That will be our second point. Okay. Now, because we have this inequality, that tells us we're going to use a solid line. So I can just draw a solid line through these 2 points. I can just get my straight edge out. And to the best of my ability, draw a straight line through those 2 points. And the fourth step is just to interpret the inequality to find the shaded region. So what I mean by that is that there's going to be a region above this green line that I drew, and that's, let's call it region A, big for above. And let's call this region below the line B. And what I mean by interpret the inequality is that we're going to look at this inequality here, and we're going to read it to ourselves as y is greater than or equal to the line. Okay, so that will tell you to highlight y is greater than or equal to. So greater than is like above. So we want to highlight above the line that we drew. So if you're doing this by hand, you'll have to grab a highlighter and say, we want to highlight everything in the region above our line. So all of this gets highlighted. And that would be it. Now, Hawks is going to be able to, when you do this in Hawks, you'll have to do this algebra by yourself by hand. And then it will ask you for some points, and you should be able to find those points by hand. And then it'll just ask you, is this a solid line or a dashed line? So you just click on solid line. And then it'll ask you which region is highlighted, the region above or the region below. And then you'll just click your selection and it'll highlight it for you. So let's go ahead and jump into Hawks just to see what that's going to look like. So I got timed out again. Let's go ahead and log in. Here we go, section 10.6, graphing linear inequalities. Right, and this is exactly what I was trying to to tell you guys before, right? Like they're going to give you this equation up here, this inequality. They'll say graph the solution set of the linear inequality. So we have to get this linear inequality into slope-intercept form, decide whether it's a solid line or a dashed line, give 2 points, and then pick the region to be shaded. Hawks is going to draw the line for you. So you don't have to wait until the third step to determine whether it's a solid line or a dashed line. Because I said before, if it has one of these symbols, it's a dashed line. And if it has one of these symbols with a little equal sign underneath, then it'll be a solid line. So right looking at this equation, I can already tell that this will be a dashed line. Is everybody okay with that determination? Or is anybody confused? Okay, and again, it just comes down to what inequality symbol are they using? So we know that this should be a dashed line. Now we can go ahead and put this thing into slope-intercept form by just manipulating it to get the y by itself. So if I wanted to get the y by itself, I could add the 2x over to the other side of the inequality so that these cancel out, and I'll get y is greater than 2x, and then I have this positive 2, so it's going to be plus 2. And that's in slope-intercept form. Does anybody have any questions about that part? Okay. Well, since this is in slope-intercept form, this tells me that my y-intercept is at 0, positive 2. So I need to plot this point here, 0, 2, or I can just go ahead and type it in because they've given me the little boxes for it. So the first point is 0, 2. That'll be my first point. And I think that once you type that in, Hawks goes ahead and plots it. So let me erase this little dot. Yeah. So I typed in 0, 2, and it put a little dot there. Now you can use the slope. And again, the slope is this number. So m is the slope. Slope is 2, or you could think of that as 2 over 1. So that's telling you go up 2 over 1. So if I went up 2 over 1, I would be at this point right here, which is the point 1, 1, 2, 3, 4. 1, 4. So then after writing that down, I'll type it in 1, 4. And when I erase the stuff on the screen, well, you can see that Hawks already put a line through it because I selected dashed line. And once I drew that second point, boom, Hawks already put the line for me. Do we have any questions up to this point? Okay, so now to determine which region we're going to highlight, we need to determine, or we just need to interpret the inequality that we have. Y is greater than 2x plus 2. This is telling me highlight the region that's greater than the line. So you need to associate in your head the word greater than means above. Highlight above the line. Now, Hawks did a funny thing and called this region that's above the line. This is above the line. Then this is below the line. And Hawks called the region above the line B. So don't get tripped up and think that above means you're going to select A. you're going to select whichever letter is above the line. So we need to select B, even though it's a little counterintuitive. Let me erase some of this. There we go. And so Hawks went ahead and highlighted in a light blue the region above the line, which is region B. Does that make sense? Okay, now if I hit submit answer, we should be good. Okay, so recap. Just by looking at the inequality, you can determine whether it's a dashed line or a solid line. You're going to make that selection. Then you're going to take the inequality that they give you, put it into slope-intercept form. That you will have to do by hand, okay? But once you have slope-intercept form, you should be able to figure out where your y-intercept goes, and then using the slope, you can find the next point. Once you type those points in, Hawks will draw the line automatically for you, and then you just need to interpret the inequality to determine whether you highlight the region above the line or below the line. Okay, let's try a similar one. Okay, so right off the bat, can anybody tell me whether this is a solid or a dashed line?
A dash.
Yeah, it's definitely going to be a dashed line. Is anybody confused as to why it's a dashed line? Okay, remember the inequality that they give us is this one, and that tells us that it's going to be dashed because it doesn't have the equal sign.
Mhm.
Okay. Now we can do some algebraic manipulation of the inequality to get the y by itself. So in this case, we'll add the 2x over to the other side. So we get 6y is greater than 2x, and then we have minus 18. Okay, this one requires a little bit more work, so I'm going to move over here so I have some more space to work. We have 6y is greater than 2x minus 18. Well, to get the y by itself, I need to divide everything by 6. So that this y, the 6 and the 6 will cancel out. So we're left the y is greater than 2 over 6 reduces to 1/3 x. And then 18 divided by 6 will still be, well, will be 3. 18 divided by 6. So this is the equation that we're going to use to solve the rest of the problem.
I don't see nothing. I don't see nothing.
Are you guys having trouble seeing what I'm writing on the screen?
Yes.
Is anybody else having trouble with the screen share?
No.
Spostati.
Let's see. Well, let me do it by hand also over here.
Okay.
Okay, so our equation or inequality was 6y minus 2x is greater than negative 18. So I said we needed to add 2x to both sides so that we get 6y is greater than positive 2x minus 18. Once we have that, we're going to divide everything by positive 6. So we can cancel out these 6's and get our y by itself. Y is greater than, and we need to reduce these fractions. So this will be 1/3 x minus 3. And so this is the inequality that we're going to work with to get the remainder of the problem solved. Okay, so the y-intercept here should be 0, comma, -3. So we can just type that first point in, 0, -3. Is anybody confused on how I got 0, -3? Okay, because I'm just pulling that -3 right out of the slope-intercept form of the inequality. Now I can use my slope and say, okay, if I plot this 0, -3, well, it's right here. Hawk's already put it here. And all I need to do is go, if my slope is 1/3, that means I'm going to go up 1 over 3. So I'm going to go up 1, and then I'm going to count 1, 2, 3. And this point right here should be 1, 2, 3, 3, comma, and then down 1, 2, -2. So that should be my other point. 3, -2. And as you can see, Hawks already drew the dashed line right through those 2 points. Now, if we're reading or interpreting our inequality here, this says that y is greater than this part. So greater than means we're going to highlight above our line, and Hawks is calling the region above A. So I will just click on A, and Hawks will highlight that region for me. And then I'll submit my answer. Any questions about that one?
No.
It's a few steps, I'll admit, but it's pretty intuitive, right? You just have to learn how to put all those pieces together. Okay, there may be some other questions in here that are a little bit more challenging than these. So I just want to find them really quickly so we can take a look at those. Because in the world of inequalities, just as in the world of equations, sometimes you get vertical lines and sometimes you get horizontal lines, and I don't want you guys to get tripped up. Oh, I guess there aren't any in the homework. I guess the department took those out. So I don't think you guys have to worry about it. But if you do run across those, then send me a message just so that I can run those back for you. Okay. Well, that is pretty much all of that section. So I think we can end there. And as always, just a brief recap, right? Today we covered point slope form. Okay, so there's a homework assignment in Hawks that's associated with that. And then also graphing these linear inequalities. They're all related to graphing these lines in the Cartesian coordinate space, but now you're having to put all of these pieces together, so that getting practice is going to be super important. So again, like I said at the beginning of class, you have homework for section 10.4, point slope form, and homework for 10.6, which is this graphing linear inequalities. Okay. Those will be due Wednesday night. And the review for the test is open through Saturday night. On Friday morning, the test will open in Hawks so that you can take that over the weekend on your own time. I won't be proctoring you. We're just going to be having to go on the honor system as far as cheating is concerned. But you will have to upload your work, which is my fail-safe for determining whether or not a student is cheating. I will know depending on how much work you put into the problem. If you somehow miraculously have all of the answers correct, but none of the work makes any sense to me, or if it's suspiciously clean the way one of these math solver apps would output the solutions, then I'm going to have a red flag and I might send you a message. But it shouldn't get to that point, right? So Wednesday, next class, our usual meeting is just going to be time for you guys to either catch up on your homework or ask me review questions. So on Wednesday at 6:15, when we usually meet, I will keep Zoom open and I'll be here to answer your questions. But if you prefer to work on your own as far as studying is concerned, then you can do that too. It is not mandatory to attend. Okay, does that make sense? But if you have any questions, you can jump in and I'll be there to answer your questions. But until that time, if you have any questions, as always, you can send me a message in Remind, send me a message in Canvas, drop by my Math World hours, drop by anybody's Math World hours. All of our tutors are waiting for you to pop in and help us kill some time, because otherwise we are bored as hell just waiting for you guys to give us problems. So make sure you're getting the help that you need, because I want you to be successful going into test 3. Okay, let's close out this semester strong. If you guys don't have any, if you have any questions, you can hang back, but otherwise you are free to go. Enjoy the rest of your night.
Thank you. Good night.
Good night.